G'day folks, well, it's time for another chapter on the Daewoo E-Tech engine, which is a General Motors Family 1 engine. I'll actually post a link to the wiki in the description, just as I have on the previous videos. I've updated them a bit. And yeah, this engine's fitted to a lot of different cars. Lots of Opels, General Motors cars, Chevys, like Chevy small cars made by Daewoo and other similar companies. This engine's in a lot of different vehicles, and it's even a variant of it still in use today. The current model Holden Cruze has it, the Chevy Cruze, same car. Yeah, they're still in use, so in one way or another. I'll have to have a look at my workmate's car. She's got a current model Cruze, and I'll have to have a look under the hood and see just what they've done to it, whether they've gone for twin cam or that sort of thing. I know they've gone variable valve timing, so I'm more than likely they'll probably just change the head and everything to twin cam. Obviously be belt driven twin cam, and probably not much else. Ignition might be coil on plug instead of a wasted spark system like that. There probably wouldn't be many differences in it. They're only producing about 98 kilowatts or something like that, which is basically the same as what the little RAV4 out there puts out now. That's a 98 kilowatt 2 litre. This is a 1.5, although I think they upped it to 1.8. It's still not a lot of difference. They're still a very small, moderately powered engine. They do their job, but that's about it. I wouldn't expect too much out of them. So yeah, I'm just getting the harmonic balancer off. I'm determined to get this damn thing off. It's smoking hot at the moment because I tried the heat and beat technique on the bolt and managed to round it off. But I've worked out it's not very solid, even though it's tight as hell. The steel it's made out of is maybe a grade 10.9 bolt, but it's nothing a high-speed steel drill won't do. Like, it only took a couple of seconds to start taking that out. So yeah, I'm just going to drill it out 12 mil, even 11.5 mil, and just rip the head off it. Once the head's gone, I can slide everything off. I'm not keeping the crankshaft or anything, so even if it's seized in there, it doesn't matter. But normally, once you get rid of the head and break that tension that's holding it all together, the rest of the thread will just spin out anyway. It'd have to be cold welded into the threads to be a real extraction issue once you've got the head off. And that goes for any bolt. Like, if that bolt there's stripped off, you could drill through there with a, well, it's an 8mm bolt, so drill through there with a 7.5mm drill and rip the head off it. Same with both of them if that was the case. Pull the housing off and then just get a pair of vice grips onto the stud that's sticking out and spin it out. Because unless it's actually stuck in the threads, in which case you'd have to drill them out and tap them out again, or put a helicoil in there. Once you take the friction away, like there's friction between the head of the bolt, the washer and the housing, that's what you're breaking free, as well as a bit of friction in the threads because they're pulling against the metal in the head. But generally, once you break the heads off them, you'll just be left with a little stub like that you can get a pair of multi-grips onto and spin it out. So there are plenty of ways of dealing with broken bolts. It doesn't matter if they're a socket head cap screw or a head stud. I mean, I could still drill into these. These are cylinder head studs, but they're 10.8 grade, and yeah, it wouldn't be a major issue to try and drill the head off one of them and release it. But of course, if it's rusted or corroded into the head, like this whole gallery or through holes full of oxide, bigger issues. Like, you'd be just prying the head up a little bit at a time. It'd be like trying to get a Jag straight 6 head off. The old J60 straight 6s had through studs and nuts, and this whole cavity where the stud goes would fill up with oxide from coolant leaking in there. And yeah, you'd need hydraulic jacks most of the time. I got lucky when I stripped down a J60. I needed very little. I used a couple of trolley jacks and blocks of wood and I managed to get it off in one night. But sometimes it can take days, weeks, just pumping the jacks a tiny bit each day and trying to get that head off. But yeah, these are grade 10.9, and you can still drill these with a good quality high-speed steel drill. Might take like a 3mm pilot drill followed by another size up and another size up. You can drill them. And then, yeah, once you release that tension under the head, pop, off she comes. It's really easy. Definitely a trick of the engineering trade and the automotive trade. But of course, just be wary of where the filings are going. If you're going to be tearing the motor down and it's an internal bolt, that's not such an issue. Like if you're going to be tanking it and cleaning it. but some areas you don't really want to be doing it, like under the valve cover. If you just want to try and, I don't know, remove the camshaft alone and not tear the rest of the engine down, you don't want that filing crap getting into the crankcase. Even though it's filtered and whatever, you get filings going through the oil pump. Well, you'll score your housing out and your gear rotors, and yeah, your oil pump's trashed. Because the filters on these are usually after the oil pump. I haven't seen an engine which has the filter before the oil pump because it can't really suck the oil through it efficiently enough. It's always high pressure out to the filter and then back to the block. Sorry, it should be the other way around. It goes into the filter through here and then back to the block through the centre. You've got more surface area on the outside of that paper element than you do on the inside, so that's your high pressure oil from the pump. That's returned to the block through the centre of the filter in there. Alright, let's give this a go. This is a brand new 5mm Sutton Viper bit. It's got a nice relief ground in it. A little bit better than what I can do freehanding on the grinding wheel, but even then some of the factory grinds you get on drill bits are absolutely atrocious. These Vipers are probably the best ones I've ever found. A lot of factory grinds, I have to regrind them straight out of the pack. They are absolutely pitiful. A little bit of coolant, not that you really need much at all. It does help though. It's just an emulsion, water oil emulsion for machining. It's getting there. I could have gone a smaller pilot drill and it seemed to have wandered off centre. Oh well. Try and get him back on centre. I could hear knocking, but I think it's just me banging into the door. That's the beauty of having a security monitor up. At least I don't have to go all the way up the front to find out what the banging is. Yeah, getting there. It might take a little while, but it's not too bad. Wow, I should have had the camera rolling for that one. Just went pop. And it ain't stuck in the threads. That was all torque. And there's nothing holding the balancer on apart from that. I was expecting a bit of crankshaft sticking out, but there's nothing there. It just went pop and the pulley flew out onto the end of the drill. No wonder it was so damn tight. There's not much holding it on. It was all that big ass kick ass washer and just pressure against that surface. Yeah, you can see where it snapped through. I was a bit off centre, but that was enough to weaken it. That is one tight ass bolt. I expected a bit of a snap and something maybe to move, but I didn't expect it to go pop and fly off onto the drill. Oh, look at that. Torque to yield. That extra length gives it a bit of a stretch. Yeah. Goes down deep and that extra length there is allowed to stretch and give it a hell of a lot of pressure. But yeah, that's come clean off. Impressive. There's not much driving that pulley. Mind you, there isn't a ton of load on it. It's just relying on this big washer and just sheer pressure against the face of the timing pulley. Well, I guess it is enough, but compared with most other engines, you actually get the crankshaft protruding through the harmonic balancer. Oh, you get a nice washer out of it. Anyway, onwards. I'll get the rest of this cover off, I think. And yeah, someone said this was a 3-wire hall sensor, not an inductive pickup. So there you go. It picks up the presence of these lugs. Obviously have some residual magnetic field, and yeah, it's a Hall effect sensor. It's all one piece. Doesn't look like it's yeah, it looks like this outer pulley's pressed on or something. It is 2 pieces, but only just. Maybe not. They might just put a parting tool down there and split it a bit, but no, it is. There's a groove in there, so there is 2 pieces to it. Anyway, if you're wondering why it's a harmonic balancer, it's because it's got rubber in between the two of them, and it helps absorb vibration, that sort of stuff. Harmonic resonance, whatever you want to call it. There's probably a more detailed write-up on how a harmonic balancer works somewhere. But yeah, there's 2 separate pieces. This outer pulley for the serpentine belts is separated by a rubber vulcanized inlay. It's not actually connected metal to metal with the centerpiece. Of course, you can get solid replacements if you're not concerned about that sort of thing. A lot of racing cars and things don't have the rubber, they just have a fully machined aluminum billet pulley, as they call it, machined from a solid slug of extrusion. I think I've got one around here somewhere. I think I've got one for a 350 Chev. It's just a solid slug of aluminium, no rubber, no nothing, light as hell, like probably a third or a quarter of the weight of this thing, or a quarter of the weight of a regular 350 Chev pulley with serpentine belt steps on it. Okay, there we go. At least you can see the belt routing here. Now it does look like I have to take it off anyway to drop the crank, because it's all part of this front casting. This whole part here behind the plastic is one piece of casting with the oil pump and everything in it. That would be an oil pressure sender. Yeah, there'll be an oil pump in there somewhere. That's probably the bypass relief, or that one of these two would be a bypass spring and plunger pressure regulator. So yeah, I'm hoping I don't have to do the same for the back, because it means taking the engine off the stand and getting the flywheel off, then putting it back on, but it doesn't look like it. Yeah, I'm hoping I can just split the sump off without having to take the flywheel off. Typically you don't. There might be a retainer or something in there, but more than likely you can do all that with the flywheel still on it. Good for in-car servicing, that sort of thing, if you want to drop the sump and just do the mains or something like that. Not that there's a lot of room to do it in a little hatch like the Lanos, but some people can. Personally I'd pull the engine out. But yeah, you can see that's our crankshaft. You've got the tensioner, idler. It's spring loaded, sort of. Actually, that's supposed to be locked in, isn't it? Sort of. See, that moves. Maybe not. Doesn't look like there's a locking bolt for it. I'm guessing it just sits there and it can allow a bit of movement. Which is a bit odd, I wouldn't expect that. See, when I first got the covers off I noticed the belt wasn't very tight, but maybe that's the nature of the beast. There's a pinhole there, but you'd only lock it in the relaxed position probably to replace it. It's not very tight. Oh well. I suppose it's only driving one cam, so as long as the belt's in good nick it shouldn't slip. It's only if you neglect them that it would slip. So yeah, anyway. That'll just slide off. The water pump will unbolt from there. It's got 3 socket head cap screws on it, but I've got to strip all this off first before I can do it. And that's the fun of some of these engines. I think Toyota does the same thing. You've got to basically do a timing belt job on it just to get to the water pump. So it's a good excuse to do the timing belt, the front main seal, oil pump seal and all sorts of things. Just like the RAV4s, you do everything you possibly can while it's open. You get the whole kit, not just the belt. Get the kit with the tensioner or tensioners, depending on what engine it is. Get the water pump, get the front main seal. The RAV4 has a cover casting with an oil pump seal and housing in it, so you do all that. Clean everything up, and even the front cam seal. loosen that off, so you take that off and do your front main cam seals and everything. That way, if anything comes up, well, it'll be later on down the track. It's not like you just did half a timing belt job and then had your front main seal start leaking because you neglected it, or spin a tensioner idler. If that's rough and raspy and you'll neglect it, well, you've just done your timing belt and your water pump. Why didn't you change that? Don't go cheap on them. I know it's easy to go cheap because you just don't have the money, but at least save up a little bit. They're cheap enough. The whole kit with the tensioners and things is really cheap. Why neglect them? Anyway, enough rambling. That should do for tonight, I think. I've got a few other things to do, so thanks for watching. Oh yeah, one last thing before I call it. As you can see, I did decide to do a little bit more. The centre pin on this is magnetised. It's not the ring gear there, well, not ring gear, but the flywheel on the harmonic balancer. That centre there is highly magnetised. It must have a neodymium magnet behind it. So I'm guessing the presence of the lugs on the timing wheel make and break a magnetic field, or at least induce a fluctuation in the magnetic field that the Hall sensors in here pick up on. So it's an interesting little concept. At least it eliminates the need to magnetise individual parts of that timing wheel, or whatever you call it. I'm going to call it a timing wheel. Yeah, so essentially if the magnetism's lost, this thing goes bad. You don't have to worry about trying to pull the balancer off and replace all of that. You just replace a simple little sensor there that I'd be willing to bet costs more than a harmonic balancer. It's kind of funny that way, but this would be more reliable anyway. You're not worrying about attaching magnets to anything and having them come off, or a couple of them go dead or something like that. It's just an all-in-one magnetic sensor with Hall sensors in it. So yeah, that's what that is. And the rest of the engine, well, front cam seal was starting to weep a bit. There's a bit of oil under there. Not bad, it wasn't running down the plastic cover. It's when it starts filling the cam cover with oil that you really got to worry about it. But I'll be willing to bet that the oil pump's in there. That bit there. So there's a high pressure to there, so that'll be a high pressure in your oil light switch. That'll be a bypass pressure regulator, and yeah, high pressure all the way through to there to the filter. You can see the casting in the block. That oval shaped rung there, cast in gallery, is a high pressure oil gallery, and it'll be machined out from the back, and yep, there's a little Welch plug in there, or a grub screw, either a Welch plug like that or a grub screw in the back where it's machined all the way through. And yeah, it comes through to here, which is, that's the inlet there, or is it? There's a ball bearing check valve in there. No, sorry, it goes through there. That's a bypass. That's the inlet to the filter. I missed that one. I just realised there's a ball bearing in there. That's a high pressure bypass. That'd probably go straight back to crankcase if there's an obstruction. While if the filter's completely blocked, I think that'll dump straight back to the crankcase. So there's your inlet to the filter. There's your outlet to the rest of the engine. Yeah, I missed that little hole. It's easy to miss that one. But yeah, that's not the oil into the filter. That's the bypass. Oil in goes from there, from the oil pump down there. So this whole front casting is the oil pump. There's no separate pump in the bottom of the pan or anything like that. And yeah, you do have to take all this off just to do your water pump. What a fun job. Anyway, definitely the last part for tonight. Thanks for watching.